Welcome back. Today we're taking a deep dive into something I think will really resonate with you, especially as someone who's deeply rooted in the Catholic faith.
Yeah.
And all those big questions about the universe, how it all began and whether there's someone greater behind it all.
Yeah, definitely. And we're zeroing in on this idea of fine-tuning, this kind of mind-blowing concept that all these fundamental constants and initial conditions of the universe, they seem to be like unbelievably precise, almost as if they were, well, set up just right for life to exist. It's a place where science and faith, those two perspectives, can actually meet and have a real conversation.
Right. And you've got a bunch of fascinating material for us to explore. Stuff about the Catholic view of creation and then whole breakdown of these finely tuned constants, all the sciencey details. So are we thinking kind of like unpack all that, figure out just how extensive this fine-tuning really is, and then what different folks, especially from that Catholic theological angle, what they make of it all? Does it point towards a creator?
Exactly. We're going to dig into all of that.
Okay, awesome. So where do we even begin with something like this?
Well, I think it makes sense to start with, the Catholic perspective. When we're talking about a universe that seems so well ordered, what does Catholic theology have to say about how we understand all of this?
Yeah, that's a great place to start.
Okay, so at the core of it, the Catholic Church, it doesn't see the universe as some kind of cosmic accident, just random chance. Instead, it sees this incredible order and precision as a reflection of God's intelligence and will. It's like, think about the Logos from the Gospel of John. That idea of God as the divine word, the ultimate source of order and reason. So all these incredibly precise constants we're seeing, it's not just some math coincidence. For Catholics, it points towards deliberate, intelligent design. Like there's a quote from Gaudium et Spes from Vatican II. It beautifully captures this. It says, "The whole of creation reflects the infinite wisdom and goodness of God." So when scientists talk about how incredibly narrow the parameters are for things like gravity or those fundamental forces, Catholics can definitely see God's hand in that providential guidance.
Yeah, that makes sense.
Yeah.
It's like when you see a super complicated machine, you just know it didn't put itself together, right?
Exactly.
Now, I've heard about this thing called the anthropic principle. It's the idea that the universe seems designed for life just because, well, we're here to observe it. Like, if it weren't life permitting, we wouldn't be having this conversation.
Right.
So how does the church view that whole anthropic principle thing?
Yeah, so the anthropic principle, as you said, it kind of suggests that our existence as observers, it makes us see the universe in a particular way. And there's logic to that, right?
Right.
But from a Catholic perspective, it feels like it doesn't go far enough.
Yeah.
It's not just that the universe, allows for life. It's that it seems almost, I don't know, perfectly set up for it, like even for intelligent life that can actually appreciate the universe and search for its origin, that deeper meaning. Catholic theology teaches that humans, we have this special place in creation, made in God's image with the ability to reason and connect with the divine.
Okay.
So this finely tuned universe, it's not just some random background, it's part of this bigger story, this story of God's love and our salvation. The fact that the universe is, as some people say, contemplation permitting, meaning we can actually understand its laws, be amazed by its beauty, suggests there's a purpose beyond just existing.
I like that. Contemplation permitting. It's subtle, but yeah, it's a really important distinction. Now, I also know the church is, careful about not using science to just try to prove God exists, that God of the gaps idea.
Right.
So where does fine-tuning fit in with that more, I guess, cautious approach?
Yeah, the church is definitely wary of just like plugging God in wherever science hasn't figured things out yet.
Yeah.
It's not a strong base for faith. Like Pope St. John Paul II, you put it so well in Fides et Ratio. He said, faith and reason are like two wings on which the human spirit rises to the contemplation of truth. So for Catholics, fine-tuning isn't like a slam-dunk scientific proof of God like you'd prove a theorem in math. Instead, it shows this incredible harmony, this alignment between what we see in the natural world and this idea of a wise and loving creator.
Okay, so it's not a proof, but it's more like...
It's this sense of awe, of wonder, that naturally makes you think about a deeper source,
So it's more like this beautiful resonance between faith and reason,
Yeah.
not a scientific mic drop.
Exactly.
You mentioned this thing earlier, the sacramental worldview in Catholicism.
Mm-hmm.
What does that even mean, and how does that connect to all this fine-tuning stuff we're talking about?
Right. So Catholics, they see the material world as more than just like stuff. It's full of these sacramental qualities, meaning it can point beyond itself to spiritual truths. The laws of nature, the intricate order in the universe, those can be seen as like reflections of God's wisdom and power, chances for us to encounter the divine. Studying physics, cosmology, it can almost become a form of prayer,
Yeah.
a way to see the greatness of God through the beauty and order of creation. Like Psalm 19 says it perfectly, the heavens declare the glory of God, the skies proclaim the work of his hands. And all this fine-tuning we're exploring, it's like the super striking declaration of God's glory.
Okay, so that gives us this really rich theological backdrop. But now let's flip over to the science side, dive into the nitty-gritty of this fine-tuning. Scientists have found a bunch of these fundamental constants that seem like insanely precise. Can we talk about some of the big ones, the most mind-blowing examples, and just how finely tuned they really are?
Absolutely. The exact number of these constants, it's kind of debated, but most scientists agree there are at least a dozen, maybe more, that seem perfectly set for a universe where life can exist. And the level of precision in some cases is just, wow, unbelievable. Let's take gravity, for instance.
Yeah, the gravitational constant, right? The one that determines how strongly things pull on each other.
You got it. It's denoted by G, and it sets the strength of the gravitational force. Its value, hang on, let me get this right. It's around 6.67430, 10 in error VCSA. Now get this. If gravity were just a tiny bit weaker by like 1 part in 10 arrow, that's a 1 with 34 zeros after it. Galaxies and stars, they never would have formed. Everything would just scattered, and if gravity were even a little bit stronger, stars would have burned out way too fast. The universe might have just collapsed on itself.
So it's like a Goldilocks situation. Not too strong, not too weak.
Exactly. It has to be just right for stable stars that can support planets and for life to, have enough time to potentially evolve. To grasp that precision, imagine trying to tweak the strength of gravity by an amount so small, it's like changing the mass of the entire Earth by the mass of a single atom. Even that tiny change would have messed up the universe big time.
Wow, 1 part in 10 euro, that's just... I can't even wrap my head around that. Okay, what about the cosmological constant? That one sounds super fundamental, but also kind of mysterious.
Yeah, it's a big one. The cosmological constant, usually represented by lambda, is linked to this accelerating expansion of the universe, and it's tied to this thing called dark energy. Its value right now is crazy small, like around 10 orders in Planck units. And the fine-tuning here, it's considered by many to be the most extreme we've ever seen. Estimates say it needs to be within 1 part in 10 years for galaxies to even form. It's like, to visualize that, imagine trying to hit a single atom on the other side of the observable universe with a dart. We're talking precision on a whole other level. If that cosmological constant were just a smidgen larger, the universe would have expanded so fast that matter wouldn't have clumped together to make galaxies and stars.
Oh, no us.
Exactly. And if it were smaller, the universe would have just crunched in on itself long ago. So that delicate balance is what allows for this stable, long-lasting universe we live in.
That's just, it's mind-blowing. All right, let's shift to something that feels a little closer to home. Something we experience every day, the electromagnetic force. I see you have the electromagnetic coupling constant on our list here. What's the deal with that one?
Yeah, so the electromagnetic coupling constant, it's also known as the fine structure constant, denoted by alpha. This one controls the strength of electromagnetic interactions, how atoms are held together, how light interacts with stuff, basically the whole foundation of chemistry. It's a dimensionless number, roughly 1137.035999. Now, the crazy thing is, if this constant shifted by even a few %, it would totally change how atoms form and whether they're stable. Like electrons might not be able to orbit nuclei properly, or chemical bonds might not form.
That's no molecules, no chemistry.
Pretty much. Without stable atoms and molecules, you can't get the complexity you need for life. So this constant, having that specific value, it's key for the whole periodic table and every chemical process that makes life possible.
So even a slight tweak and the whole structure of matter just falls apart.
Yeah, pretty much. And that brings us to the strong nuclear force.
Okay, so the strong force, what does that one control? And how finely tuned is its strength?
All right, so the strong nuclear force is the muscle that holds protons and neutrons together inside the nucleus of an atom. It's got to be strong to overcome the electromagnetic repulsion between those positively charged protons. Compared to electromagnetism, it's about 137 times stronger.
Whoa.
And the fine-tuning here is critical. There's this theory that if the strong force were just a teeny bit stronger, like 2% stronger, all the hydrogen in the early universe would have fused into helium.
And what would be wrong with that?
Well, No hydrogen to fuel stars like our sun. No hydrogen for water, which, as you know, is pretty essential for life.
Oh, right.
And if the strong force were weaker, even by just 5% atomic nuclei, besides the really simple ones like deuterium, they wouldn't be able to hold together at all.
So no heavier elements.
Exactly. We wouldn't have carbon, oxygen, all those crucial building blocks for life. So the fact that we have this variety of elements, it all comes down to this super delicate balance.
And we can't forget about the weak nuclear force, right? What does that one do in this whole intricate setup?
Yeah, so the weak nuclear force is responsible for some types of radioactive decay, and it's involved in nuclear fusion in stars. It's a lot weaker than both the strong force and the electromagnetic force, but it's still crucial. If it were too strong, certain elements would decay too quickly, or the balance of those nuclear reactions in stars would get messed up, potentially affecting the production of elements that are essential for life. And if it were too weak, some important nuclear processes, like hydrogen fusing into helium in our sun, wouldn't happen efficiently enough to keep stars burning for long periods. So it's like this behind-the-scenes player, but it's still vital for a stable universe that's rich in the elements we need.
We've only scratched the surface here, and I'm already amazed by the level of precision required. I see you've got a whole bunch more listed: the ratio of the mass of a proton to an electron, the charge of an electron, even fundamental constants like the speed of light and Planck's constant. It's almost overwhelming to think about how many of these things seem to have to be just right.
Oh, it's truly remarkable. Like, take the mass ratio of protons to electrons. It has to be within 1 part in 10 years for atoms and molecules to form and stay stable. Change the electron's charge a bit, and the whole strength of electromagnetic forces gets thrown off, totally changing how atoms interact. Even the speed of light, while we define it as a constant, its value is super important for the relationship between space, time, and energy in Einstein's theories. Mess with that, and the consequences could be huge, probably destabilizing the whole universe. Planck's constant, that defines the scale where quantum effects become important, and its value is crucial for the stability of atoms and how matter behaves at those tiny levels. If it were different, quantum mechanics, the whole structure of atoms, it could all be radically different.
And then on top of all these fundamental forces and constants, you have the initial conditions of the universe. Things like the initial entropy, the density right after the Big Bang, and how fast the universe is expanding. Those sound pretty important too, right?
Absolutely. The initial entropy of the universe, that's basically its starting level of order, had to be unbelievably low. Roger Penrose, he's estimated the fine-tuning for this to be something like 1 part in 10 to the power of to the power of a 123. It's a number so huge it's almost meaningless to us. If that initial entropy had been even a tiny bit higher, the universe would have just reached a state of like thermodynamic equilibrium super quickly. There wouldn't have been any energy gradients to drive the formation of stars, galaxies, or life. The density of the early universe, that had to be incredibly fine-tuned too. Just 1 second after the Big Bang, estimates say the density had to be within 1 part in 10 unit of this thing called the critical density. If it weren't that precise, the universe would either instantly collapse under its own gravity or expanded so fast that no structures could form. And the expansion rate of the universe, governed by the Hubble constant, that also needed insane precision in the early stages, around 1 part in 10 year, to allow the universe to expand and cool down at just the right rate for galaxies to form and light elements to be synthesized in the early universe.
So it's like the universe wasn't just playing by finely tuned rules, but it was also dealt a very specific hand right from the start.
Exactly. And the more you dig, the more examples you find. You've got the slight asymmetry between matter and antimatter, which is why matter is dominant today. You have the specific energy level in carbon-12 nuclei, the Hoyle state, that helps produce carbon in stars. The tiny mass difference between neutrons and protons, which is crucial for stable atoms. The fact that we live in 3 spatial dimensions, not 2 or 4, which would mess up atoms and planetary systems. The ratios of dark matter and dark energy to regular matter. Even the teeny fluctuations in the early universe's density that acted like seeds for galaxies to form. Every single one of these parameters seems to fall within this incredibly narrow, life-permitting range.
Thinking about all this, it's hard not to go back to that watchmaker argument we touched on before. Given all this scientific evidence, does that analogy still hold up today?
Well, the original watchmaker argument from William Paley, it said that finding a complex, purposeful object like a watch naturally leads us to think there must have been a watchmaker. The modern version, looking at this fine-tuning of the universe, argues that the cosmos, with all its constants perfectly balanced for life, shows even more complexity and purpose than any watch. So the argument goes, it's reasonable to think there's a cosmic watchmaker, a divine designer. This idea that all these constants could randomly fall into their life-permitting ranges, it's so incredibly unlikely that it becomes a central part of this updated argument. It goes beyond the complexity of living things, which Darwinian evolution explains, to the very foundation of physical reality, the laws and starting conditions.
So the focus shifts from the details of life itself to the blueprint of the universe.
Precisely. It's all about the foundation, the ground rules of existence. The argument emphasizes that this fine-tuning isn't just luck. It creates a universe that not only can support life, but seems almost set up to do so. The level of precision, like that 1 part in 10 Uris for the cosmological constant, that kind of accuracy, if we saw that in something humans made, we'd instantly know it was intelligently designed.
And how does Catholic theology fit in with this line of reasoning, this idea that the universe is rationally ordered and seemingly designed?
Catholic theology, as we talked about before, has a long history of seeing the order and intelligibility of the universe as pointing to God. God is the eternal logos, the source of divine reason. St. Paul writes in Romans 1:20, "For since the creation of the world, God's invisible qualities, his eternal power and divine nature, have been clearly seen, being understood from what has been made." These scientific discoveries about fine-tuning definitely resonate with that theological idea. The universe isn't a random accident, it reflects this underlying intelligence and purpose. Pope Benedict XVI, he said it beautifully. He said the universe is not the result of chance, as some would want to believe. Contemplating it, we are invited to read something profound into it, the wisdom of the Creator. And going back to Pope St. John Paul II and Fides Ratio, he emphasized how faith and reason work together. He suggested that scientific exploration can deepen our appreciation for God's creative work.
It seems like everything points towards this idea of a universe with the fingerprints of intentional creation all over it. But I know there's another explanation that comes up a lot, the multiverse hypothesis. What is that, and how does it try to explain this fine-tuning?
Right, the multiverse hypothesis. It's a popular counter-argument, especially among those who hold atheistic or materialist viewpoints. They struggle with this fine-tuning problem. So they suggest that maybe our universe is just one of many, perhaps an infinite number of universes, each with its own random set of physical constants and initial conditions. Their thinking is that if you have enough universes out there, just by pure chance, some of them are bound to have the right mix of values to support life. So we just happen to be in one of those lucky universes because, well, we couldn't exist anywhere else. This ties back into that anthropic principle. Our existence as observers determines the kind of universe we see.
So it's like saying our universe just hit the jackpot in a cosmic lottery with an unimaginable number of tickets.
Yeah, that's a common way to put it. But here's the thing. When you think about how precise even one constant needs to be, like the cosmological constant at 1 part in 10 degrees, the chances of randomly getting a life-permitting combination across multiple constants, it becomes mind-bogglingly small, even with a huge number of universes. We mentioned Roger Penrose earlier. Even though he's not a theist, he's expressed serious doubts about the multiverse as a good explanation, simply because the odds are so astronomically against it.
And are there philosophical issues with this multiverse idea too?
Oh yeah, several. For one, it can feel like it's not really explaining anything. If you're saying there are infinite universes with every possible configuration, some argue it doesn't really answer why our universe is the way it is. Then there's the fact that the multiverse is, by its very nature, super hard, if not impossible, to test scientifically. We can't observe or interact with these other universes, so it remains largely in the realm of philosophical speculation, not hard science. And lastly, some argue that even if there is a multiverse, it doesn't get rid of the need for an ultimate explanation. Many theologians and philosophers point out you can still ask, where did the multiverse come from? What determines its properties?
That's a great point. Even with a multitude of universes, you still need to explain where that multitude came from. So from the Catholic perspective, does the idea of a multiverse even fit in?
For Catholics, even if science proved the multiverse existed, it wouldn't change the core belief in God as creator. Catholic theology sees God as more than just a being within the universe, or even within a multiverse. God is the ultimate source of everything, the reason anything exists at all. So even if there were many universes, their existence and how they work would still depend on God's power to create. The intelligibility and fine-tuning in our universe could still be seen as evidence of God's wisdom and design, whether or not other universes with different properties exist.
So as we wrap up this deep dive, what are some final thoughts on this question of design and intentionality, considering all of this evidence of fine-tuning in the universe, especially for someone looking at it from a Catholic viewpoint?
Well, in a nutshell, when you consider the sheer number of physical constants and initial conditions that seem to be perfectly fine-tuned within these unbelievably narrow ranges that allow for life, and you add in the incredibly low probability of these values happening purely by chance, it makes a strong case for intentional design. While this fine tuning might not be a strict scientific proof of God in the traditional sense, it aligns incredibly well with the Catholic understanding of a rational and purposeful universe created by a wise and loving God. For someone grounded in the Catholic faith, this offers a compelling perspective that brings together scientific discoveries and deeply held beliefs about creation and a creator. It encourages you to go beyond a general belief in God to a deeper appreciation for the incredible precision and intricate beauty of his creation.
This has been an incredibly thought-provoking deep dive. For you, our listener, as you reflect on all of this, maybe think about how understanding this fine-tuning of the universe might impact your prayer life, deepen your sense of awe and wonder at God's creation, or enrich those conversations you have about faith and science with others. Keep exploring this fascinating intersection of your faith and the incredible discoveries we're making about the natural world.
It's a journey worth taking.
Absolutely. Until next time.
Take care.